Now in hydrodesulfurization, isomerization was on there. Oh, there it is up there. Hydrocracking's in there too. The actives on the hydrotreating catalysts are generally metal oxides, nickel, cobalt, nickel, molybdenum, and actually when you buy it, it's an oxide, and then a lot of times you'll pre-sulfide a catalyst, and you'll put sulfur on it. You'll convert that metal oxide to a sulfide. So there'll be a pre-treating step on a new batch of catalyst. You call it pre-sulfiding. So that's the active form for those catalysts. And sometimes a lot of your catalysts, particularly cracking catalysts, will have strong acids in there and even bases. Hydrocracking, alkylation, FCC also should be on there. And okay, that's probably enough on catalysts. What else we got? Okay, now I want to start with a simple flow diagram before we go to that complicated one. Let's see now, where is that? Okay, yeah, I think it's... Okay, I guess we can treat. How did we do that again? How did we? Oh, was right.
That's a different program.
Yeah, that one doesn't have the possible capability. Well, we can do this, of course.
Yeah.
That didn't do much, did it? How about that? Still didn't do much. Anyway, this is a.
Play might work on it.
Which one?
On the toolbar.
On the top toolbar.
Top toolbar.
But I don't even know.
Down one tool.
Oh, I see it. Right there.
Right.
Okay. This is a very simplistic diagram. Two feeds coming in, oil and makeup hydrogen. And they'll usually mix ahead of the heat exchange train. Keep in mind these are around, 200 degrees or something. And this is coming off a makeup reciprocating compressor, so maybe it's 250 degrees. All right, well, typically we want, at least 500 to 700 in here. So you have a heater, of course, but you want to minimize the size of that heater and the emissions on that heater. Right now in a refinery, to try to add a new heater in California is almost impossible because they won't permit the heater. Those heaters give you NOx and SOx and particulate, so they don't want to let you have a new heater. So you minimize the size of these heaters. You do it with heat exchange. This is going to take a temperature rise. We already said a good 40 degrees maybe. So we might as well take advantage of that and recover that heat. So we exchange the feeds with, that shows one exchanger. It easily could be 10 shells. So anyway, so heat it up the best you can. Now fired heater. And one thing to remember on heaters, now this is exothermic process, so the heaters generally aren't that big. Now in an endothermic process, which you'll see maybe next week I'll do a little reforming, but there you need a lot more heat because you have to supply, not only get the reactants up to the temperature you want in order to react with the catalyst, on the catalyst, but then you have to supply that endotherm. It cools down, and you have to supply that. This is exothermic, so these heaters don't tend to be as big as like a reforming heater, which is an endothermic process. I presume everybody knows what endo and exo mean.